Introduction to proofs. So a mathematical proof involves taking a mathematical statement and then providing arguments that guarantee a conclusion. And there are quite a few different proofs that we're going to look at in further videos. And here we're just going to focus on some notation that we can use. So let's have a look at a few symbols. So we have this symbol here, means for all. We have this symbol, which means belongs to. We have this symbol, which means there exists. We have this symbol, which we should be used to, being therefore. This symbol for such that. This symbol, which we can use for real numbers. We have this symbol for implies that. We have this symbol for logical equivalence. And we have this symbol for not. Now, let's also talk about a few things that we're going to use in our proofs. So the first thing we want to talk about is negating statements. So for example, if we have x equals 2, a negating statement for x equals 2 is that x cannot equal 2. If we have x equals 2 and x equals 3, the negating statement would be that x cannot equal 2 or x could not equal 3. If we had a statement that said x equals 2 or x equals 3, the negating statement would be that x cannot equal 2 and x cannot equal 3. So if we had let's look at how maybe we can use some of the symbols. If we had 2n equals n squared, is true for all values of n, we could say, sorry, it's not true for all values of n. We could say there exists an integer n such that 2n equals n squared, because we can provide one example. For example, when n equals 2. Because if we had 2 times 2 is 4, and 2 squared is also 4. So this leads us to say that if we're going to use the symbol there exists, we only need to show one example for this to be true. Because if there exists one example, that statement will hold true. And if we're using the symbol for all, it'd only take one example, so this one example to prove this one's true, it'd only take one example to show this statement was false. because we're saying for all. So if we show that one example is false, that would prove that statement to not be true. So it'd prove it to be false. Also, let's say we have if n ends with the digit 2, this implies that n is even. And another way we can use logical equivalence. We could say that if we have x equals 2, a logical equivalence to that would be that 100x equals 200. And these are just some examples on how we can use some of this notation when we're doing our mathematical proofs.